Welcome to qnawire.
On question 93, they tell us we're working with the molecule ethanol, that's C2H5OH. And they tell us that at 19 degrees Celsius, the vapor pressure for ethanol is 40.0 torr. They say that we have a 1 gram sample of ethanol and it's placed into a container with a volume of 2.0 liters. And the temperature again is at 19 degrees Celsius. And it says if the container is closed and the ethanol is allowed to reach equilibrium with its vapor, so this was liquid to start with, how many grams of liquid ethanol remain? So what we need to figure out is how much of the ethanol is going to vaporize, and we can figure that out using the vapor pressure. And we're going to be using the ideal gas law on this problem. And what we're going to solve for, so the ideal gas law is PV equals nRT. And what we want to solve for is when the vapor pressure when it hits equilibrium and it's at its vapor pressure, and we know the volume, this is the 2.0 liters, how many moles of gas are there? Because if we can figure out how many moles of gas there are, then we can know how many grams of gas there are, and then subtract that from the total mass of ethanol put in, and we'll know how much is left as a liquid. So we're going to solve this equation for moles, so that's PV over RT. And then in order to use the constant R that is equal to 0.0821 liters times atmospheres per mole times Kelvin, we need our temperature to be in Kelvin for one, so we're going to add 273 here, and we get 292 Kelvin. And we're going to convert from torr to atmospheres. So there are 760 torr in 1 atmosphere, and that is equal to 0.0526 atmospheres. So I'm going to plug all the information into the ideal gas law solving for moles. So the pressure when it's hit equilibrium and it's at its vapor pressure is the 0.0526 atmospheres. The volume is the 2 liters over R, which is 0.0821 liters times atmospheres per mole times Kelvin times the temperature in Kelvin of 292. And from that we find that we have 0.004388 moles of ethanol. I'm not going to round too much because we're in the middle of a problem here. Now I'm going to take that number of moles of ethanol, so my 0.004388 moles of ethanol, and I'm going to convert it to grams to figure out how many grams of the ethanol are changing into a gas. So for every 1 mole of ethanol, the molar mass of ethanol is 46 grams, because that's C2H5OH. And that gives me, that's my 0.20 grams of ethanol. Since I started off with 1 gram, I'm going to subtract off the 0.20 grams, and that leaves me with 0.80 grams of ethanol that is left as a liquid. The rest is up here in the gas state.